Welcome to Module MU003 of Oricon's Upskill Modular Training Program devoted to Revit and BIM. This module is titled Air Balance Calculation Using Spaces and is brought to you on behalf of Oricon by A2K Technologies. We will be using the purchased material supplied by Oricon and A2K Technologies. Classroom notes and handouts are available for note-taking through the Exemplar portal. Throughout the training today, we will be covering the following topics: spaces and rooms, heating and cooling load analysis, creating a space schedule, calculated values, and conditional formatting and verification. Introduction. To follow this lecture, start Revit and open up the file titled Master MEP Mechanical MU003. The views referred to in this module can be found in the project browser under B Working and Mechanical. Open the floor plan titled O1 Entry Level. Go to the visibility graphics by typing VV and ensure here that the relevant mechanical categories are switched on. Then click OK. Zoom in to the top left-hand corner of the plan between grid lines A and B and notice that there is a simple mechanical AC layout pre-modelled here made up of a small fan coil unit and some ductwork feeding 6 air terminals. Spaces and rooms. We are now going to place a space over this room so that we can schedule it. Open up the visibility graphics by typing VV and ensure that the spaces category is ticked on and click OK. Then go to the Analyze tab and select the Spaces tool from the Spaces and Zones panel. Place this new space inside the room where the AC layout resides. Select this new space and refer to its properties. Scroll down and under Identity Data, notice the architectural room name and number coming from the linked ARC model. Adjust the space name and number to match the room details, 121 and cafeteria. Click Apply. Scroll down to the energy analysis parameters and set the space type to dining area. This is important as this setting will drive the results from the analysis we are about to run in the next step. Click OK. Space and building type settings can be found in the MEP settings on the Manage tab of the ribbon. Space type settings can be found here, and if we scroll down the list and select dining area, we can see the energy analysis settings that are used to calculate for this type of space. This is what Revit uses to calculate the heating and cooling loads. These values can be adjusted by the user if required to achieve more accurate results. Select the cafeteria space once again and also refer to the mechanical flow properties. Notice that other than the actual supply airflow, all other values are currently at 0. This is because we have not yet run any analysis tools to find the heating and cooling loads, so let's look at that in the next section. Heating and cooling loads. From the Analyze tab of the ribbon, select Heating and Cooling Loads from the Reports and Schedules panel. The Heating and Cooling Loads dialog box will open. Keep in mind that this tool requires that there are spaces present inside the model to work. Without spaces, it has nothing to analyze. We can see that there are a handful of spaces already defined in the model so far, including the one we have been looking at, the cafeteria. The dialog displays the information and settings relating to the makeup of the building construction and those assigned to each space, along with a 3D view highlighting the position of the spaces in green. The user can modify these settings to the desired project-specific requirements, but for this exercise, we will leave the settings as is and run the analysis. Click the Calculate button. A loads report will be generated for the project and saved in the project browser under the Reports heading. Close this down and also notice that if we now interrogate the properties of the space, the calculated supply airflow values are now populated. In the next section, we will look at scheduling the space and using some of these valuable flow calculations for airflow design verification. Creating a space schedule. Go to the View tab on the ribbon and select Schedules button. And from the pull-down list, select Schedule Quantities. From the New Schedule dialog box, choose Spaces from the category list and give your schedule a name, Airflow Check. Click OK. From the Schedule Properties dialog box, we now need to add the parameters that we want to display. From the available fields list on the left, select the following parameters and click the Add button to add each into the Schedule Fields list on the right. Number, name, area, level, calculated supply airflow, and actual supply airflow. These parameters should now be listed on the right-hand side in this order. Click OK and you should see the schedule created, displaying these parameters in that order. You can adjust the columns by widening them to fit the appropriate heading text. You should see a few spaces including the number 121 cafeteria room. This is the one we are going to focus on. Let's isolate this cafeteria space in the schedule so that we can more clearly work on it. We will use a filter to achieve this. Go to the Filter tab of the Schedule Properties and apply the following filter. Filter by number equals 121 and click OK. You should now see this cafeteria space isolated in the schedule. This schedule is allowing us to compare the calculated supply airflow with the actual airflow data from the model design for this specific space. Calculated value. We will now create a calculated value to further compare the calculated flow with the actual flow. Go to the Fields tab of the Schedule Properties. Click on Calculated Value button. In the Calculated Value dialog box, set the following. For the name, call it Airflow Check. The discipline will be HVAC. The type will be Flow. The formula will be Calculated Supply Airflow minus Actual Supply Airflow. And click OK. This newly created value appears at the bottom of the scheduled fields list. Click OK again to now see this airflow check column in the schedule. This calculated value helps to flag problem areas where spaces may not meet the required airflow rates. Conditional formatting and verification. The final step in this exercise is to apply some conditional formatting to further assist in flagging potential problem areas. Go to the Formatting tab of the Schedule Properties dialog box and highlight Airflow Check from the list on the left. Then select the Conditional Format button. In the Conditional Formatting dialog box, set the following: field to Airflow Check, test will be greater than, value will be 0 litres per second, and then set the background colour for this rule to be red and click OK. Click OK once again and go to the Filter tab and remove the rules we applied earlier so that all spaces will again show in this schedule. We can remove this filter by setting the rule back to none. Click OK. You should now see that all values that are greater than 0 will highlight red to identify a potential issue. In other words, these spaces will have less than the required flow that has been calculated. Engineers and designers can now utilise this checking method to run through the entire model as it gets populated. And this now concludes our module MU003, Air Balance Calculation using Spaces.